Algebra 2 class of 2018. This is a fresh video for you guys and for whoever else might watch this in the future. So we're going to do lesson 77, advanced radical equations, and there's a second part called multiple radicals. So let's talk about how we solved radicals in the past. This is a radical equation right here. It's a radical equation because it has a radical in it. So if you remember how we solved this, we square both sides, because when we square both sides, we get rid of the radical. When you square a radical, you get what's underneath it. So we're going to get x minus 1 equals 16. Add 1 to both sides, and we get x equals 17. With these problems, you always have to check them. Anytime it's a radical problem, check it, because sometimes it throws out an answer that doesn't work. But when we put this back in, 17 minus 1 is 16. We square it, we take a square root of it, we get 4, and 4 equals 4. So that one works. So let's try our new problems. They're very similar, except you're going to see that we have a cubed root, and we have a trinomial underneath the radical. So first thing you're going to do is isolate the radical. So I'm going to take my radical, cube root of x cubed plus 6x squared minus 4, and I'm going to get it all by itself by moving the negative x minus 2 to the other side, adding x to both sides, adding 2 to both sides. Now instead of squaring it, we're going to cube both sides because it's a cube root, such as this. On the left side, it's easy. When you cube a cube root, you get what's underneath it. However, on the right side, when you cube a binomial, we are basically taking it times itself 3 times. So we're going to use FOIL. First, we're going to get x squared plus 4x plus 4 times x plus 2. So I FOILed these first two. And then I'm going to take x times all 3 of them and 2 times all 3 of them, and I'm going to combine my like terms, and we're going to end up getting x cubed plus 6x squared plus 12x plus 8. So that's what happens when we distribute the x plus 2 through the x squared plus 4x plus 4. Now we're going to simplify. The x cubes cross each other out. The 6x squareds even cross out, which is nice. They make these problems so they turn out very, very nicely for you. And then I'm going to subtract 8 from both sides, and I'm going to get negative 12 equals 12x, and we get x equals negative 1. When we check this, which you should do when you have a radical equation, you should check it. It does work. When we put the negative 1 back in here, we do get 0. So it's worth the check. All right, that was if you have a cube root. The second type of problem we're going to do are when we have multiple radicals. Whenever you have multiple radicals, you want to isolate the bigger one, get rid of it, and then you'll have another radical that you'll have to get rid of. So we're going to isolate this radical right here. So we get the square root of k minus 5. Everything else is going to go on the other side. So we're going to have the square root of k minus 1. Then we're going to square both sides. So we'll square it like this. You have to square both parts, both sides. And when you square the square root, we're going to get k minus 5 on the left. And on the right, I'm going to FOIL it the mature way. So we square the first term. Square root of k times square root of k is k. Then we're going to multiply them together times 2, so we're going to get negative 2 root k, and then we're going to square the negative 1 and get plus 1. And again, the k's cross out. I'm going to subtract the 1 from both sides, and we're going to get negative 6 equals negative 2 root k. Divide both sides by negative 2, running out of room here, so we get k, so root k equals 3, and then we just square both sides. So we get k equals 9. So we're squaring both sides like this. K equals 9, and we should check it. And again, all the examples seem to, actually, they don't all work out because the next one doesn't work out, but this one works out as well. If you put it up here, the square root of 4, the arrow thing, the square root of 4 is 2, minus the square root of 9 is 3, plus 1 does equal 0. So let's do our last example, and then I have the practice problems you're going to do, which is like doing your homework anyway, but I'm going to have the solution for you. Same thing, isolate the radicals. So root x minus 8, we're isolating the bigger radical, equals 2 minus root x. We're going to square both sides, and we get x minus 8 equals 4 minus, we're going to FOIL it. So you can write it out twice if you want, but I'm trying to teach you how to do it the more mature way, which means you square this one, you multiply these two together, take it times 2, so it's going to be negative 4 root x, and you square the last one, which would just give you x when you square that. The x's subtract away. We're going to subtract 4 from both sides, so we're going to get negative 12 equals negative 4 root 3 root x, and we get x equals 3. When we check this, we're going to have a problem. We're going to put this up here. We're going to put the 3 in, so we're going to get, let's see, where did the original problem go? Oops, I forgot to square them. Duh. Okay, hold on. Square root of x equals 3, so we get x equals 9. I was wondering why that didn't work out. So we're dividing it by negative 4, and we still have this radical right here, so we get x equals 9. Put it back into the original problem, so we're going to get root 9 minus 8 plus root 9 equals 2, and we're going to get 1 plus 3 equals 2, and we get 4 does not equal 2. So if that's the case, you write no solution. All right, hopefully this lesson's pretty easy. I think it is compared to some of the last ones we've done. Okay, last ones, we're going to do the practice problems. So I'm just going to help you out with those. You can either look in your book or you can just copy it down from here. This is practice problem A. So turn the video off, push pause, and give it a try. All right, here we go. Isolate the big radical. So we have the cube root of x cubed plus 3x squared minus 8 equals x plus 1. Everything else goes to the right. We're going to cube both sides. Hopefully you did this and you're just not copying down what I did, because I'm going to go rather fast in this one. So we get x cubed plus 3x squared minus 8 equals, and if you FOIL that all out, you get x cubed plus 2x squared plus x plus 2x plus 1, which simplifies into, I just wrote out my second step, into x cubed plus 3x squared plus 3x plus 1. When we combine our x squared terms, I lost my x squared term here. This should have been, I forgot my x squared term, x squared. Okay, and that would be x cubed plus 3x squared minus 8. The x cubes cross out, the 3x squareds cross out. We're going to subtract 1 from both sides, so we get negative 9 equals 3x, and we get x equals negative 3. I checked that one, it does work, so that's our solution. Let's try one more. This is practice problem B, so try it, stop the video, and come back when you're done and see if you have the right answer. All right, hopefully you paused it. So here we go. I'm going to isolate the bigger radical. Square root of x minus 16 equals 4 minus the square root of x. Square both sides, which will get rid of the radical on the left side. So we get x minus 16. On the right side, we're going to FOIL it. We get 16. If we multiply these together, we get negative 4 root x. Take it times 2, which is going to be negative 8 root x, plus x. Now the x's cross out, and we subtract 16 from both sides, so we get negative 32 equals negative 8 root x. Divide both sides by negative 8, we get 4 equals 4 equals root x, and we get x equals 16. And when we check it, that too works out, so we have a solution. So that is it for lesson 77.